chance to say hello and take a look at our Math 1108 Sections L Practice Final Exam. This is just a sampling of the kinds of questions you're going to have. And again, if I were a student, I'd pause, write it down, and then wait, give it a shot and see how the answer works out, and then continue to play to see the protocol for solving. So this is an absolute value of 15, which is 15, and then is less than or equal to 15. Now, when we said we had this kind of inequality symbol, as long as part of this was true, this was true. So 15 does equal 15, so this one is true. Now, in this example, and we can call it example 2 or question 2, this is what we might have seen. This is a polynomial, and they're asking us to factor this polynomial in by grouping. Factor this by grouping. So the protocol for that was, out of these first two terms, can we take out anything common? And you might say, yes, we could take out a 2x out of these, and we're left with 2x plus 5. And then as we look at the second two terms, we could factor out a positive 3 and get 2x plus 5. So now we have factored common factors by grouping, and then what do we have then left? Well, if we were to factor this, we'd say, well, we have common factors here of 2x plus 5. That would be these two. And then we just put in the 2x plus 3. So we have factored out the common factors. But that's not the question they're asking here. They're asking us to multiply and then group like terms. So when we do multiply this, we get this. And then now when we group our common middle terms here, we get 4x squared plus 16x plus 15. And that's what they're looking for. Again, here they're telling you, multiply and simplify. Now I'm using this to illustrate factoring by grouping. Or if you had originally the two binomial factors, you would take this and multiply it by this. That's what this is here. And then this and multiply it by this. That's what this is. And then you get this. But we can also wanted to review the reverse process. Now here we're going to convert the log form to its exponential form. See if that'll help us in solving for y. So our base is 4. Our exponent is y. And our answer is 64. So what exponent of 4 raises it to 64? Well, 4 to the third power is 64. So your answer is y equals 3. All right, hopefully something easy. Now for example 4, as we read it, 8,000 invested at 9%, compounded continuously. What will be the balance after 9 years? Well, you recall the formula for continuous interest is A equals P, Euler's E, RT. So see if you can put that into this form. So that would be A equals 8,000, Euler's E. The rate now, there's an exponent there, 9%, so 0.09. And T is years times 9. Put that into your calculator and see what you get. Well, it should come out to this, because this was correct. Now for question 5, this is our function formula. So it'd just be a matter of substitution, 700. Now, since it's 1 plus this decimal fraction, we can just write it 1.122. That is, do the addition of what's inside here. And then now our exponent x we see is 6 months. Raise that to the 6th power and see what you get. Well, this is the answer, and again, correct. Now for example 6, they're giving us a quadratic equation in standard form, and they're going to ask us to solve it by the quadratic formula. But to do that, we have to identify our A term, our B term, and our C term. Now I have said it's much easier to solve when your A value is positive. So I'm going to multiply each of these terms by a -1 and therefore change the sign. So the -1 here became a +1. The -2 became a +2. And the +2 became a -2. Now in the next slide, they're going to ask us to put this into the quadratic formula, which I'll do right here. And you can do it along with me. So x equals a -b. Well, here b is 2, so a -2 b would be a -2, plus or minus the square root of b squared, which is going to be 4, squaring this b, minus 4 in the formula. A now we know is a +1, and c is a -2. So again, putting it in there correctly is super important. And this is now all going to be over 2a. A is 1, so this is 2. So we've substituted. Now as we look at this, we see a negative times a negative here. We'll make this positive. So 4 times 2 is 8, plus 4 is 12. So our next line is 2 plus or minus the square root of 12 all over 2. Now remember, this 12 is the discriminant. This indicates we're going to get 2 answers. And let's go to the next slide. Now they want us to simplify this. And as I said, we're getting 2 answers. So I've selected two answers. This gives us then two boxes. But notice the answers are not what we have here because this isn't simplified yet. So we're going to simplify it. So a -2 plus or minus. Now 12 was the square root of 4 times the square root of 3. The square root of 4 is 2. The square root of 3. Now I could do it this way. Put each of these over 2 or factor out a 2. There's a number of ways. But now this cancels out and becomes a -1. Here the 2's cancel out and we get plus or minus the square root of 3. So they want you to write this as two answers. So -1, negative square root of 3. -1 plus square root of 3. And there are my answers. So again, a check on the use of the quadratic formula, identifying your A, B, and C, putting it into the formula, and then simplifying. In example 7, they're asking us, and this is going to be in 3 parts, studying this, what form is this equation in? Well, it's point-slope form. And they're asking, what is the slope? And then what is the ordered pair that you're to pick out from this equation? Well, what's in the M position is 3/4, and then your Y value and your X value. And the key to remember here, the shortcut was it's the opposite signs of these. So our value for X is going to be a +3, and our value for Y is a +2. And that's what we've put here, and that is correct. So as we go on to the next part of this, they're going to ask you to plot this point, 3, 2. So we've done that, 3, 2. Now as you plot the slope from this particular point, your slope is 3/4, and there are again ways to do this. So I had suggested you do the X positive run first. So 1, 2, 3, 4. Mentally you put a dot there, and then you're going to go up 3. So 1, 2, 3. So on the next slide you plot this point, but you have to have some notes to know where this is. So you had to, this one sort of disappears on the next slide. But from that point, 3, 2, you go over 4, up 3, put your second point there, and then the graph will form, and there you see it. And this is correct. So again, being able to pick out your slope and the point from this. Now I've seen other examples just for review if it looked like this. Y equals 3/4 X minus 3. Now that's not in slope-intercept form, but a modified form of the point-slope form. Now what would it look like if you had the full thing? Well, this would be Y minus 0. And then the 3/4 X minus 3. So what would be your ordered pair then? Well, we know the slope is still 3/4. But the ordered pair for our X value would be a +3. But now, since there was no y value, it was a 0. So 0 doesn't have a sign, so we just put it like that. It's your x-intercept. And then from this point, you would do the over 4 up 3 to get your second point. All right, so a little background. Remember, these are just possible kinds of things you're going to get on your final exam, and things that we've covered through the course. In example 8, this was our original equation. Now, notice it's not in standard form. So as I studied it, I says, oh, I'm going to write it on my paper in standard form. So x to the third, transpose the positive x squared to the left side where it becomes a negative 7x squared. The negative 18 is x is already there, equal this is 0. Now, step 1 is see if there's a common factor, which there is. So we get x. In fact, I'll go to the whiteboard here. And I'll take this away here. And we get x squared minus 7x minus 18. This would be line 2. And then now we're going to factor this part, x. Now, factors of 18, this is negative, this is negative, this is going to be a difference of 7. So you brainstorm and you end up perhaps with 9 and 2. 2 times 9 is 18. We need a negative in the middle, so our larger, the outers, which will be a negative, and then the inners would be a positive. So we factored that correctly now. Now we equate each of these factors to 0. And then our three answers then are x equals 0. Now for this one, we transpose the positive 2. We get x equals a negative 2. Transpose the negative 9. This is going to be x equals 9. And we'll go back to our regular board, and we see the answers listed there. But this is the protocol to do it. And again, often take a moment to study what you're doing and then decide what strategy you're going to use to solve. Now for example 9, they're giving us a system of linear equations, and fortunately they've graphed them for us. We're looking what would be the ordered pair of the point of intersection. So you go over 1, so this is a 1, and then you go up 5, and this is a 5, and there's your ordered pair. And it's right there. So again, something rather straightforward. Let's go down and see the answer. 1, 5. And every once in a while, something rather easy. Here you're just simplifying this improper fraction. 3 goes into 42 14 times. So again, every once in a while, a super easy one here. Let's go on. Now here again, something from earlier lessons dealing with 3 fractions, and they want us to add them together. Well, you can make it more challenging or less challenging. What's our common denominator of these 3 fractions? You said 8. That's correct. So this is going to be a +1 right there in the middle. Now, if I wanted to make 1/4 into a denominator of 8, I'd have to multiply it by 2/2. So this new fraction would be 2/8. So there's 2/8 over our common denominator. And this one is also 2/8 using that same technique. So now we have a common denominator. We just add our numerator and we get 5/8 as the answer. So again, testing your skills of working with fractions. In example 12, we have a word problem. If 21 is added to a number, so there's the number, we're going to add 21 to it. The results, that would be equal, is 36 less than twice the number. Well, twice the number less 36. So again, it may take time to get the equation, but we want to solve it. So to keep my x positive, I'm going to subtract an x here, subtract an x there, and this just becomes x. Transpose -1x, 2x gives me a 1x. Now to bring this to the other side, I'm going to add 36, or just transpose it. So x is 57. Going on to our next example. Now again, we should pause, study it, and see what they're asking. Well, they want us to multiply these binomials, but this is a special product. These are conjugates. Conjugates, when they're multiplied, end up with the difference of perfect squares. The middle terms cancel out. So as we do our first, we get 9x squared. As we do the last, we get a -25. So multiplying conjugates gives you the difference of perfect squares. If you have the difference of perfect squares, they will factor into their conjugates. Now, if this were just for a little something extra, an equation, and it was equal to 0, to solve this, again, each of these factors are equal to 0. This would become 5/3. That is, transpose the -5 and then divide by 3. And this would become a -5. Transpose the +5, divide by 3. Now, they're not asking that here, but as a review item. Now, in this example, they're giving us an inequality. So they're asking us to solve it, put it in interval notation, and then graph it. So let's go to the whiteboard to do this. We transpose the +1. On this side, it becomes a -1. So 7 minus 1 is 6. Now, to isolate the x, we're going to divide both sides by a 2. Now, since it's a positive, we don't have to do any changing of the direction of this inequality sign. So our algebraic answer is x is greater than 3. Now, in interval notation, in fact, let's do the graph first. This is going to be a 3. And what symbol are we going to use there? Well, a parenthesis. because the 3 is not included. And this is going to go to positive infinity. So in interval notation, this would be 3, comma, positive infinity. Now, when you put that into your graph, you have to select the signs at the end. So they would be parentheses. Move the dot to a 3, and then move this parenthesis to the end where the ellipsis forms, and that would be the correct graph. So now let's see it in real life here. So there's our interval notation. And let's go to the graph. Takes a moment. And there's the graph. So you chose a set of parentheses that forms, and you have to move it to 3. And then move the last parentheses so the ellipse shows. And that is example 14. Now we're halfway through. If you want to take a break, you could pause it now, but I'm going to keep this just as one video review. So in example 15, we're asked to find the mean. That would be the average of this, the median, and then the mode. This is going to be in 3 parts. We'll use this to illustrate all 3. So here, they're not in any particular order. So for the median, we're going to have to put them in order. So let's do that. So that would be 4, 5, scanning them, 9, 10, 12, and then 14. So we have 1, 2, 3, 4, 5, 6. We add all of those up, get a sum, divided by 6, and I believe it's 54 because the X bar for the median is 9. So that's the strategy. Now for the median, since it's even, we have to go to the 2 that are in the middle, and that'd be a 9 and a 10. And we have to add those together, divide by 2 to find the median. And that'd be 19 divided by 2 is 9.5. That would be the median. And then for the mode, is there any item that's repeated more than once? No. So there is no mode. And as we move through these, you'll see the answers. So there's the mean. Takes a moment. There's the median. And there is no mode. Okay. Now, for example 16, again, you'd pause, read it. They give us everything we need here. A equals, you have 320. That's the principal. And the formula's right there, so it'd be 320 again. Now the rate is 12%. We need to convert that to its decimal form. And the time is 15 months. Well, 15 months is 12 months plus 3 months. 12 months is 1 year. Time is in years. And 3 months is 1/4 of a year. So I'm going to use the 1.25. Now you could put in this position 15 over 12. If you're going to put it in the calculator, it all works out anyway. So when you get this, you get an answer, and you add it to this, and it comes out to be $368 is your future amount. And again, you want to physically try this to be sure you're knowing the protocol to use in an example if you get one like this on your final exam. Now for number 17, we have the acronym, Please Excuse My Dear Aunt Sally. So as we look through this, we're asked to simplify. The first thing is what's in parentheses here. This is an 11. Exponent is going to be squared. So this is going to be 121. And we have to do the multiplication, which is 6. So even though it may have looked challenging, it's pretty easy. 127. So looking at this next one, again, we talked about technique for this. And the technique would be to substitute into your formula, in a sense, where x is, you're going to put in parentheses the -3. So then, working this out from this, -3 squared is a positive 9. -4 times a positive 9 is a -36. This is a -12, and then plus 2. So we can subtract the plus 2 from the -12 and get -10. -10 and -36 is a -46. So sort of straightforward. Now this is in 2 steps. They're going to give us another value shortly. So in part 2 of this example, we're just using now a 4 to substitute for the x, which I've set up. Now we're going to square the positive 4, get 16. -4 times 16 is a -64. A positive 4 times 4 is a positive 16. Plus 2. So this gives us a positive 18 and a -64. When we do that addition, we end up again, interestingly, with a -46. So again, some of these in substitution just need to be careful of the signs, and hopefully a good place to earn points. In question 19, we're asked to solve this equation. So again, with a little study, and I'll go to the whiteboard, we want to isolate the x term. It's on the right, that's fine. We're going to transpose this to the other side, where it becomes a positive 14 and a -10. So this is 4 equals 4x. So we just divide both sides by 4, and we get x equals 1. So again, the examples we're getting aren't that challenging. Maybe on your final, they may be a little bit more challenging, but you want to deal with protocol here. So there is the answer, x equals 1. All right, let's go on. Okay, so we're dealing with sets now. And we're looking for strategy, and then what are they asking us? Well, this symbol is union. So now we're going to list all of these elements, but not repeating any. So you need to put a brace in there, and then start your collection of elements here. So the lowest, and put them in order too. So there's 3, 5, 6, 7, 8, 8, 9, 10, 11, and 13. And as I mentioned, don't put a comma by that last one. And this one's straightforward as long as you know the symbols. Now, if they ask for, let's just do it. Suppose they're asking here for intersection. A intersecting with B. All right, here you'd have to see which ones are in both. So you have a 5, a 7, a 9, and an 11. So that's what you would put in your braces. All right, let's go on. Now in example 21, they're dealing with probability, and it's kind of a simple one. What is our total? Well, our sample space is 88. Just adding these two together. And they want to note probability that no headphones. Well, that's 60. So when you reduce this to lowest terms, you get 15 out of 22. And I believe you're going to factor a 4 out of there and get 15, and a 4 out of there and get 22. Now again, since this is a final exam, you're getting a little bit of everything. Here they want you to solve for P. So I equals PRT. So you're going to divide both sides by the factors you don't want, RT on this side, RT on that side. Here these cancel out, and you're left with P equals I over RT. Again, hopefully something that's well mastered at this time. So just a few more to go. Here we're asked to find the product of 5 and an X and a Y. Well, this is just straightforward. 5XY. Product. Now, if they said the sum of this, it would be 5 plus X plus Y. And again, depending upon what they're saying, you want to reflect that in your answer. In this example, they're asking us to find the slope of these two ordered pairs. Well, this is the formula, so it's -6 minus a -2. So minus a minus makes this a +2. And then 7 minus 5. So this gives us a -4. This gives us a +2. That simplifies to a -2 over 1, but we don't write the 1. And there's our slope. Now, for undetermined, if you had something like 5 over 0, that would be undefined. Now, I was wondering if they were going to ask us for an equation with fractions, and here is one. Now, as we look at this, again, study. You could multiply everything by 24. That would get rid of the fractions. But there's another way too, and again, thinking that some of you sometimes like different ways, I'll show you the other way. I'm going to take this, since these are like denominators, move it over to the other side where I get 9/8 minus 5/8. All right, that's sort of interesting. So I get 5/24 x equals, would you all go along with 4/8? And what is 4/8? 4/8 is 1/2. Okay. So this is the other way. I thought we'd just try something out here. And now we can use the reciprocal to isolate the x, which I wanted to review. And then this side by its reciprocal of this term. And then now all of these cancel out. We're just left with a 1x. And then 2 will go into there once. 2 will go into there 12 times. So we get 12/5. Now, doing it the other way, you'd get the same answer, but this was something a little different, and there are different ways to get to the results. And let's see what we have here. 12/5, let's clear it up, and 12/5. All right, we're just 2 more to go here. Now, for this one, they're asked to find the slope and the y-intercept. Well, we know y equals mx plus b. So if we put that in that form, y equals a negative 2x plus 5. So our slope then is a negative 2. And our y-intercept, don't forget to write it as an ordered pair, in parentheses, 0, 5. So again, something easy. Now in part 2, they're asking us to graph this. So our y-intercept is a positive 5. We put a dot on 5. And then lift up our mouse and go to a negative 2/1. So we're going to go to the left 1, up 2, put our second dot there, the line forms, and there's the graph of this particular equation in slope-intercept form. Now for our last question here. So again, these were just a sampling of the kinds of things you're going to get on your final exam, reflecting what we did through the term, and whatever technique you're going to use now to collect like terms. So again, different methods, a negative 5x, a negative 8x, just getting all of our like terms together, and then a positive 7x. These are all the like terms. And then we have a negative 6 and a positive 3. Well, if we take a positive 7x from a negative 8x, we're left with a negative 1x, and a negative 5x gives me a negative 6x. And then a negative 6 and a positive 3 leaves us with a negative 3. Again, hopefully this was helpful. When you study, you want to look over your notes carefully, reflect on what you have, but keeping in mind it's not going to be as difficult as any single test might have been, but a compilation of everything we've done and a reflection of what we did this term. Good luck and hopefully success in the course.